Okay, in section 3.3, we're going to talk about different ways to solve quadratics. Okay, the different ways we're going to do are by factoring. We're going to use the square root method. We're going to use completing the square, which we worked on the other day for graphing. We're going to use the quadratic formula. And we're going to use graphing. Okay, so we're going to use all those methods and different ways to solve quadratics. Okay, so in this quadratic, this is to do it by factoring using the zero product property, which basically says if I have two things that are being multiplied together, two factors, and that's equal to 0, I know that one or the other or both have to be equal to 0. One of them has to be a 0 for the whole thing to equal 0. So the way we do this is we factor this. You did this back in Algebra 1 and Algebra 2 as well. So factoring, just like we've done in the review, we look for GCF first. So we take out the x squared. Okay. After we take that out, we continue to factor. This would be x plus 4 and x minus 2. Okay, now to solve it, we want to set each of our factors equal to 0. Okay, so when I set this equal to 0 here, I'll zoom in a little bit more so you can see. There's no x to solve for. It doesn't make any sense. We don't use it. Subtract your 4 to the other side, you get x equals negative 4. Add your 2 to the other side, you get x equals 2. And there you go. You solved it. Got your answer. Okay. Thinking about this one, factoring it, we can take out a GCF of an x. Okay, can't factor any farther. So set your factors equal to 0 and solve it. So I know 0 is one answer. Subtract that 9 over, you get negative 9 is your other answer. Okay, once again, factoring. Okay, this is a greatest common factor pattern. So 3x plus 5 and 3x minus 5. Set them both equal to 0. Okay, so here you would subtract your 5 and divide by 3. And here you would add your 5 and divide by 3. Okay, so 5/3 and negative 5/3. Okay, try and pause these and do them yourself if you can. Okay, but once again we factor x minus 3 and x minus 7. Set those factors equal to 0. So you get x equals 3 and x equals 7. Okay, we first, I don't know if I mentioned this because these are already like that. We first want to get them equal to 0 before we start factoring. So we're going to subtract the 30 over and get it equal to 0 first. Now we're ready to factor. Okay, let's see. So 3x and 3x multiplied to give you 30. 6, negative 6 and positive 5 give you negative 18 plus 5 is 13. Okay, sometimes that takes a little bit of time though, so take your time with it if you need it. Okay, solve it. Subtract your 5, divide by 3, negative 5/3, and add your 6. And with all of these, you can always check your answer by taking them and plugging them in. So if I take 6 and plug it in here, square it times 3, times, subtract it, it'll equal 30. Okay, this is a 4, by the way. Okay, so with this one here, no greatest common factor, so we're trinomial, we're going to do this. I believe it's 3x and 2x, 4 and 1, or 2 and 2, 2 and 6 and 4, it won't work. 4 and 1 would be negative 1 and positive 4. Okay, so we set them both equal to 0. Okay, subtract the 4 and divide by 3, and add the 1 and divide by 2. So 1/2 and negative 4/3. Okay, next one here. Once again, we want to get it equal to 0. So we'll subtract that x over and subtract the 4 over with the like terms. So we have x squared plus 10x plus 25. Okay, and we notice this is a perfect square trinomial. Half of this is 5. 5 squared is 25. Okay, but if you just factor it normally, we know it's x plus 5 and x plus 5. And if you set them both equal to 0, they both give you the same thing. You get x equals negative 5. Okay, this one too, get it equal to 0. So we'll have 4x squared plus 44x plus 96 equal to 0. And this one does have a greatest common factor. They're all divisible by 4. Okay, and then we have something that's easier to factor. And 24 would be 8 and 3. So I get x equals -8 and x equals -3. Remember, if you set 4 equal to 0, it doesn't have any x's there with it, so you just kind of ignore that in solving. Okay, in this one, you could subtract this over, but I like to keep this one positive. So I'm going to keep 2x squared positive, subtract the x over, subtract your 21 over. Now I have it equal to 0. Okay, so no greatest common factor. You want to factor it out. 2x and x give you 2x squared, probably 7 and 3, and yep. So it'd be 6 and -7, and set them both equal to 0. You get 7 halves and -3 are your two answers. Okay, so with all of these, one way to do it is this is solving by factoring. Okay, this is our solving by factoring method. Okay, the next method is the square root method. Okay, the square root method, you can't use that when you have an x squared term and an x term. Okay, we're only going to do this when you see a squared term with it using the square root. So what we're going to do is try and get that square root method by itself. So you get x squared. Hey, sorry, my kids didn't need me there. So x squared would equal -5. Okay, and we can take the square root of both sides. Square root is opposite of squaring. So I get x equals, you have to take the plus or minus, because if you remember, like x squared equals 4, right? If you have x squared equals 4, x could either equal 2 or x could equal a -2. Okay, so you notice how we get two answers there. So we have the plus and the minus. And then the square root of -5 is I square root of 5. Okay. Okay, next one. Okay, we want to get the square by itself, so we're going to divide by 2. So we have x minus 1 squared is equal to 7. Now, we can get rid of the square by taking the square root, both sides. So we have x minus 1 is equal to plus or minus the square root of 7. And last step, to get x by itself, we want to add 1 to the other side. So we're going to have 1 plus or minus the square root of 7. Now, if you wanted to, you could put that into decimal form. 1 plus the square root of 7 is something. 1 minus the square root of 7 is another decimal, but it's okay to leave it like this. Okay, here, notice, once again, there's no x term with it, so there's just an x squared, so we can subtract that 3 over. So we have 9x squared is equal to 108. Divide by the 9 to get the x squared by itself. And lastly, take the square root of both sides. And don't forget the plus or minus. Okay, plus or minus the square root of 12. I think we did a little bit of simplifying of these this year. 12 is 4 times 3. Square root of 4 is 2. So we have 2 square root of 3. So plus or minus 2 square root of 3. You could also put it into a decimal form. Next one. Subtract your 14 from both sides. Okay, get rid of the 1/3 by multiplying both sides by 3. So you get x squared is equal to 36. Take the square root of both sides, you get 6. Oh, that's not the only one though. Plus and minus 6. Okay, so that's the whole idea of taking the square root method. That's method number 2. Now this method you cannot use when you see like x squared and an x term. Okay, this is only when you see just an x squared by itself can you use this method. Okay, next, completing the square method. Okay, so we worked with completing the square the other day, right? So if you remember, what we're going to do first is we want to be able to complete the square. So I'm going to take this 56 over to the other side by subtracting it. And we have to complete our square now. So we have to take half of this and square it, just like we did the other day. Half of this is -9. -9 squared is 81. And what I do to one side, I noticed in your homework some of you didn't do this, if you add it to one side, you have to add it to the other side to keep this equation balanced, right? We want this side to still equal this side. So here, when I solve that, when I factor it, x minus 9 times x minus 9, and on this side I now have 25. Okay? Now, we can, sort of like what we did up here, we can get rid of the square, so take the square root of both sides. So x minus 9 is equal to And the square root of 25 is 5, so plus or minus 5. Last step is to get x by itself, add that 9 over, to get 9 plus or minus 5. So 9 plus 5 is 14. 9 minus 5 would be 4. So we solved it. We got our two answers there. Now, if you would do this by factoring, you could do the same thing. It'd be x minus 14 and x minus 4. But when you set those equal to 0, right, just like we did up above, you get 14 and 4 are your two solutions, okay? So completing the square is another very good method. Okay? Now, when completing the square, just like we did before, we don't want to have 2x squared, we just want to have x squared to complete the square. So first step is to divide everything by 2. And as long as I divide everything by 2, both sides, they're still going to be equal, right? This side's still going to be equal to this side. Okay? So even though I divided by 2, this is still equal to that. Okay, now I'm ready to complete the square. So half of 8, negative 8, is negative 4. Negative 4 squared is 16. And what I do to one side, I have to do to the other. So this right here factors to be x minus 4 squared. X minus 4 times x minus 4. Add these together, I get 1. Okay, then I want to work this out, solve it out, get rid of the square. So take the square root of both sides. So x minus 4 equals plus or minus 1. Square root of 1 is 1. Okay, and then lastly, add 4 to the other side. So I have 4 plus or minus 1. So 4 plus 1 is 5. 4 minus 1 is 3. I have my two solutions. Okay, this one here, I'm going to divide everything by 4. So I get x squared minus 2x equals negative 3/4. I want to complete the square now. Half of negative 2 is negative 1. Negative 1 squared is 1. So add 1 to both sides. Okay, factor this down. This would be x minus 1 squared. Add these together, I get 1/4. Or 0.25, either way is okay. Square root both sides. Okay, square root of 1 is 1. Square root of 4 is 2. So you get 1/2. And you will add your 1 to the other side. So it's 1 plus or minus the 1/2. So we get 1.5 when you add and subtract, you get 1/2. Or if you want to, you'd be 3/2 and 1/2, either way you look at it. Okay, so that's how you complete the square. Okay, so here's a couple more to complete the square. I encourage you to pause the video and get some practice doing it, and then come back and watch me do it. Okay, so what I'm going to do is add the 21 to this side here. Okay, so we're going to add 21 to this side. So I have x squared plus 16x is equal to 16. Okay, think about what will happen there to complete the square. Okay, you take half of 16 is 8. 8 squared is 64. So you want to add that to both sides. Okay, this right here factors to be x plus 8 squared equals 80. And then square root of both sides. Plus or minus the square root of 80. And lastly, add the subtract the 8 over. So negative 8 plus or minus the square root of 80. Okay. Now, I'm not going to be picky about this right now, but 80, if you take the square root of 80 and break it down, okay, that would be 16 times 5. Square root of 16 is 4, so you'd have 4 square root of 5. So you could write this as negative 8 plus or minus 4 square root of 5. You could also take this and take negative 8 plus the square root of 80, and you get like 0.944. And you could take negative 8 minus the square root of 80, and you get negative 16.944. Okay? So either way, you write your answer there is okay with me at this time. Okay, next one. This is going to get a little more complicated because when we divide by 3, we got some fractions here, right? So we're going to have x squared plus 10/3 x. And I know I have to also bring this over, so I'm going to do that in the same step. So minus 8/3. Okay, now I got to complete the square. Half of this would be 10 thirds, 10 sixths, which would be 5 thirds. Squared gives you 25 ninths. Okay, that could be as a decimal too, but it's not going to be a nice decimal, so fraction's better. Okay, if you take this and factor it down, it'd be x plus 5 thirds. And the way, for those of you that, okay, if you take 10 thirds, divide it by 2 is the same as multiplying by 1/2. That'd be 10 sixths, which is, whoops, you can't see that. If you take 10 thirds, dividing by 2 is the same as multiplying by 1/2, which would be 10 sixths, which is 5 thirds, okay? And when I squared that, 5 squared is 25, 3 squared is 9, right? And we also know that half of it is 5 thirds there. Okay? And if I add these together, if you're trying to do this in your head, get 9. So we have 25 ninths, and this would be times 3 on both sides, right? So it'd be negative 24 ninths. So when you put those together, you get 1/9. Okay? Use Desmos if you need to as well, though. Okay? And we're going to take the square root of both sides. So x plus 5 thirds. Square root of 1 is 1. Square root of 9 is 3. So plus or minus 1/3. And we're going to subtract that over. So negative 5 thirds plus or minus 1/3. So if you take negative 5 thirds plus 1/3, you get negative 4 thirds. And that minus a third would be negative 6 thirds, which would be negative 2. Okay, so this completing the square method will always work as well. It's just that sometimes it's a little messy when you have to deal with a lot of fractions. Okay, we'll do one more here. Okay, we want to get everything divided by 4. So you get x squared, that's plus 19 is equal to 4x. Now, this isn't in the right form yet, so I'm going to arrange this stuff a little bit. So I'm going to have x squared. I'm going to subtract the 4x over here. I'm going to subtract the 19 over there. Okay, now I'm ready to complete my square. So half of this is negative 2. Negative 2 squared is 4. So complete the square by adding 4. This right here is x minus 2 squared. And this right here gives you negative 15. So now, take the square root of both sides. Plus or minus the square root of negative 15. Add 2 to the other side. So you have 2 plus or minus. Okay, now what do we do with the square root of a negative? It's an imaginary number, right? Okay, so I squared of 15 there. And there's your answer. We get our two answers, 2 plus this and 2 minus this. We have the two answers we get with quadratics. Okay. Now the quadratic formula, hopefully you guys have this memorized, but let's derive it. Okay, let's see how it works here. We're going to use completing the square. Okay, so first thing is to do is divide everything by a. 0 divided by a is still 0. Okay, so we'd have x squared plus b over ax equals negative c over a. Subtract that over. And if we take half of this and square it, we get plus b squared over 4a squared plus b squared over 4a squared. If you take this, it'd be x plus b over 2a, like half of that, right? And if you need to square it, you can think about that squaring idea. And over here, we talked about that. We kind of did one this the other day. We wanted to get these to be common denominators, right? So you have to multiply by 4a and multiply by 4a. Then, if we just kind of switch it around, it'd be this minus 4 multiplying by 4a there over 4a squared if we have common denominators. Next step is that we take both square root of both sides. Right, if x plus b over 2a is equal to positive or negative of this. Okay, and we're going to add this over, subtract this over. And the last step is if I take the square root of 4, it's 2, and the square root of a squared is a. So notice we have the same denominator. So we have common denominators. Okay, so if you ever wanted to know where that quadratic formula came from, there it is. I think sometimes, probably in Algebra 1 when you worked with this, your teacher probably just gave it to you. You didn't really derive it and know where it came from. Here's where it came from. So here is our quadratic formula. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm sure your teacher sang it to you. If not, you're robbed. Yeah. Okay, so we're going to use the quadratic formula. Remember our a, our b, and our c, right? So we would have negative 14 plus or minus the square root of 14 squared minus 4 times 5 times 3, all divided by 2 times a. Now, the minimal amount of work I want you to do is to show all this, okay, and then start working it out. So we'd have negative 14. I want you to work out the inside part here. This part inside here is called the discriminant. Okay. Okay, the discriminant tells us how many solutions it's going to have. Okay, if it's positive, and we'll talk about that later, but if back in Algebra 1 and Algebra 2, if it's positive, you get 2 answers because you get plus or minus. If it's 0, plus or minus, you get the same answer. And if it's negative, you get imaginary answers. Okay, but anyway, well, 14 squared minus 4 times 5 times 3 is 136. And 10 on the bottom, so I want to see that step. And then from here, I'm okay if you put it into decimal form and give me the decimals, or what I would really prefer is if you simplified it. So 136, okay, the square root of it, is 4 times 36. Okay, and the square root of 4 is 2, so we'd have 2 square root of 36. Ideally, I'd like you to do this. So we'd have negative 14 plus or minus 2 square root of 36 over 10. And then divide, all those are divisible by 2. So you'd have negative 7 plus or minus, I'm sorry, 34, not 36. 34 over 5, which would be your final answer there. Okay. This one here, first we have to get it equal to 0. So we're going to add the 42x over and subtract the 3 over. And now I can have my a, b, and c. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Next step, work out your discriminant. Negative 42 plus or minus, okay, 42 squared minus all that gives you 1800. And 1800, okay, square root of 1800 here. Let's see. Not divisible by 81. Well, let's do this. Okay, we know it's 2 times 900. Okay, and 900, the square root of 900 would be 30. Okay, so if this one would be 30, and we're left with the square root of 2. Okay, so this would be the same thing as negative 42 plus or minus 30 square root of 2 over 6. And then we simplify. We can divide a 6 out of all 3 terms. So that divided by 6 is negative 7. And divide by 6 gives you 5. Okay, so we have our answer. You could also put it in decimal form, but I think I'd rather prefer you to do this. Okay, next problem here. That's a 17, it's hard to see there. But we need to get this stuff over here, right? We can, in this problem, it doesn't really matter if we leave this negative, so we'll do that. We'll just leave that negative 2x squared. You can make it positive 2, taking over that way. But minus 8x, subtract your 1 over, add your 1 over, gives you plus 18. So with the quadratic formula, you don't really need to have this as positive x squared like you do with a lot of the other methods. The quadratic formula is nice because it works all the time, okay, no matter what you have. Okay, so we go negative b. I kind of want to do that because it just show you this here. Plus or minus the square root of b squared minus 4 times a times c, divided by 2 times a. Okay, so we get 8, and if you work out the discriminant, that comes out to be 208 over negative 4. Okay, the square root of 208, oh man, I don't really know, so I'm going to break it down. 208, let's say 4. Okay, so 4 and 52. Okay, I think 52 will go farther yet too, though. Yeah, 4 and 13, okay? So I have the square root of these numbers here. Square root of 4 is 2. Square root of 4 is 2. And then the square root of 13 doesn't break down any farther. So we have 4 square root of 4. You couldn't see that. So that breaks down to 4 in this and 4 in this. Square root of 4 is 2. Square root of 4 is 2. Square root of 13 does not simplify. So we have 4. 2 times 2 is 4, square root of 13. Okay, that's a simplified form. So we have 8 plus or minus 4 square root of 13 over negative 4. Once again, these are all divisible by 4. Actually, let's divide them both by negative 4. So 8 divided by negative 4 would be negative 2. And that divided by that would be plus or be negative, but since it's plus or minus, it just changes the plus to a minus and the minus to a plus. So we have negative 2 plus or minus the square root of 13. Okay, next one. Get it equal to 0 first. Subtract your 4x over. Subtract your 5 over. Negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Work the discriminant out. That's 4 plus or minus the square root of negative 64 over 10. Okay, square root of a negative 64. Negative makes it imaginary. Square root of 64 is 8. So it works out to be that. And then we can divide 2 out of all those. So it would be 2 plus or minus 4i over 5. Okay, the last method we're going to talk about is to solve by graphing. And this is really the easiest method, especially if Desmos. Desmos makes it so easy. Basically, just graph this. When you graph this in Desmos, you get a graph something like this. And we want to see where it's equal to 0. Okay, so if we look at this, we get it equal. Get this here. Okay, what I'd actually like you to do is get this equal to 0 in Desmos. Okay, so we can graph it like y equals, and if we add this over, we'd have x squared plus 16x. Add this over, would be negative 16. Okay, now if you graph this in Desmos, you'll get a graph that looks like this. Our solutions are where this is equal to 0. So where it's equal to 0 would be right here, and it'd be about 0.944. And right here would be negative 16.944. Notice we did that same exact problem up here. Okay. Now, the bad part with Desmos is it won't give us in this form. By looking at graphing, it won't give us this form, but we do know the decimals. So it'd be real easy to take this, put it in decimal form, go to Desmos and check yourself. Make sure you have it right. Okay. So we already have this equal to 0, so that's sort of like our y equals. And we get a graph that looks like this. Now, does this graph ever equal 0? No. So there is no solution. It's never going to be equal to 0. Okay, the y. The y gets up to, I don't forget how high, but it'll never get up here to 0. Okay, the next one here, if you graph this, it's already equal to 0, so you have y equals this. And the graph looks like this. And if you click on this point right here, it comes up to be negative 0.666666 repeating, which is, hopefully you know, is negative 2/3. Okay, and this just touches one time, just barely touches. Most of the time, most quadratics are going to have 2 solutions, right? But not always. Sometimes they only have 1 solution or no solutions. Okay, last one here, we want to get it equal to 0 first. So 5x squared minus 4x, subtract that 5 over, be plus 4 equal to 0. And then in Desmos, y equals this, and you get a graph that looks like this. Once again, never crosses your x-axis here, so never equal to 0, so no solution. Okay, so we talked about over the last 2 days 5 different ways of how to solve quadratics: factoring, square root method, completing the square quadratic formula, and graphing. Factoring can be used on some but not all things, only ones that can be factored. And really, if I would just make up some numbers and put them in here, most things can't be factored. It's just that we math teachers give you ones that can a lot of times. Remember, the square root method can only be used when you see an x squared. The completing the square method can always be used. Quadratic formula can always be used. Graphing has its limitations because it only gives you decimal answers, and it won't tell you imaginary answers. It'll tell you that there's 2 imaginary answers here, right? We know there has to be 2 answers, but it won't tell us what those imaginary answers are, so that's kind of limited too. Okay, so those are the notes.